Hello everyone. In this program I'm going to be explaining to you the working of the logical shift right instruction, and that logical shift right instruction is going to be helping us in dropping out the first nibble of a particular data that is provided. For example, if this is your data available with you, you are going to drop off this particular data that is available here, and you're going to replace this more significant byte over here with the least significant byte of data. So this is the one that you're going to be doing over here. So you're going to drop out these values. So what is happening over here? You're dropping the first nibble value. Nibble means 4 bits. So you're dropping out these 4 bits and you're going to replace these 4 bits by these 4 bits over here. So that is what you're going to do in this particular program. So we are going to write an assembly level program. So for that, what you're going to do first is you're going to move the value FF into the R1 register. So this is where your input is available. After you move this value FF into R1, you're going to start by logically shift right. So which means you're going to shift it towards the right side. I hope you can see the difference between this statement and the statement over here. What are you doing over here is this is your input, which is going to be FF. If you're shifting it to the right, what is happening? This first byte of data will come to the second. This second will come to the third over here. This third will come to the fourth data, and so on all the way. And what you're going to replace is the most significant byte is going to be replaced by 0 because you're going to use logical shift right. If you're using logical, you will not use the carry bit, you will just be replacing it by zeros. So this is going to happen if you're going to shift it by one time. So if you're shifting it by one time, you can see that FF has now become 0111 followed by 4 ones, which is equivalent to 7F. 0111 is equal to 7F over here. Similarly, if you're going to shift this data two times, what is going to happen? You're going to have two zeros in front over here, and this two ones are going to be available here, and these four ones are the ones that are going to be available here. These two ones are going to be dropped off. So you have 0011, which is nothing but 3F. Okay. Similarly, if you're going to shift this data three times, you can see that you will have three zeros over here. If you're going to shift it four times, you're going to have four zeros over here. And what is happening, you can see that this 1111 after you shift four times is going to be available here, and this 1111 has been dropped off. Okay, so this 1111 has been dropped off. That is what our question is about. We need to drop the first nibble using the logical shift right instruction. So you're going to drop off this first instruction, and after I do this, what is going to be my final output? You can see that FF in R1 is now going to be updated with the value 0F. Okay, and that is what is seen in this program, but the output is going to be available in which register? It is going to be available in the R10 register. Okay, you're going to logically shift right by 4 bits. After you logically shift right by 4 bits the value which is FF, you can see that you're going to be getting 0F, and that 0F is going to be available in R10 register. So now when we execute this particular program, you can see what is going to happen. Now debug. So you can see that first my value of FF is moved to R1 register. R1 register initially is having a 0. So when I run it, you can see that FF is now being available over here in R1 register. Now what am I going to do? I'm going to logically shift right it by 4 bits. If I'm going to logically shift it right by 4 bits, you can see that I will have 0000 followed by 1111. So what is going to happen over here? I'm going to have 0 and 1111 is nothing but F. So I'm going to have this particular value of 0F, which is going to be moved to R10 register. So R10 register, which is initially 0 here, is now going to have the value updated as 0F. Now if I run it once more, you can see that it has now become 0F. So in case if you're shifting it by 4 bits, you can see that you'll be getting 0F. Similarly, if you had shifted it by 3 bits, you can give it a try. You would be getting 1F over here in this R10 register. If you shift it by 2 bits, you will be getting 3F. If you shift it by 1, you will be getting 7F, and so on. So either you can move a byte of data, you can move a nibble of data, and so on. If you want this entire 8 bits of data to be moved outside, the number to be specified over here, any guesses? You just need to be putting a value 8 over here. If you put a value 8 over here, the entire FF value will be removed outside, and at the output of this R10 register, as you guess, you will not be having 0F, you will be having 00. So insert same value, FF being your input. If you're giving LSR hash 8 over here, what is going to happen? You're going to shift it right by 8 bits. If you're shifting it right by 8 bits, this 1 will be shifted out finally, and you'll be getting all values to be 0. Okay, so LSR 8 is nothing but 0000 followed by 0000, which is nothing but 00. So the hexadecimal 00 will be the one obtained over here. So This example I hope you can understand. You're just dropping the first nibble that is available here. So for that first nibble you have to give the number 4. If they have been asked you to drop a byte of data, please remember you have to adjust the number over here. You just don't have to change any other value. You just need to adjust the number of shifts that needs to be taken care. Thank you so much.